So in this video, I'm going to break down the structure of unit tests that I think is appropriate for enterprise and industry level applications. This is also suitable, of course, if you're working on your own project or if you're just 2 or 3 team members in your team. But specifically, I'm talking about from my experience within Microsoft working on big projects. I'm talking about hundreds of partners or hundreds of developers working on the same project. So the principles that I'm going to outline today are relevant for projects that have 3 people, but they're also relevant for teams of hundreds of people working on the same project. So what I want to focus on today is specifically the structure and how to build your unit test infrastructure in a way where you're creating a small testing framework for you and your team in a way that scales well as you refactor, you add more tests, more team members are joining, and the previous ones are leaving. How to set the correct foundation for your unit tests to thrive in the long run. Now, before we begin, I do want to emphasize that even though I work at Microsoft, I'm not talking on behalf of Microsoft. The things that I'm presenting are my personal opinions. The methodology that I'm going to lay out today is going to be what I would actually take if I were to build a project from scratch today based on my experience. Now, I've done this specific pattern in multiple projects, either new projects or projects that I entered that were already very big. And it's amazing to see how once you have the correct structure in place, then how new tests and new utilities or test utilities that are added with time align with the foundation that was laid down. Okay, so let's jump right in and look at an example. We're going to use the Boober Dinner application. This is a project that's built following clean architecture and domain-driven design. Okay, so if we look at what we have over here, then we're looking under the main folder, the root folder of our application. We have right away all our various projects, right? So this is the actual infrastructure project. This is the actual contracts project. So the first thing we want to do is go ahead and create a source folder where the source code will sit. So for that, let's say make dir source. So we have the source folder, which contains the source code. We have the documentation and the requests in corresponding folders. And then we have here general things like the global JSON, the directory.build.props, and the solution file. So we have here everything that we want. The next thing we want to do is create a new folder for the tests. So I say make dir tests. Okay, like we said, we have the source and the tests. All our tests will sit under the tests. Now we're going to create a folder for each type of tests. So let's create a folder called unit test, and any other test type that you would have would also sit in the corresponding folder. I'll create a few just for reference so you have it. Okay, now the reason why we want to do this is, as you can see, we already have 5 projects over here where each one of them will probably have unit tests, or almost each one of them is going to have unit tests. But if it also has integration tests, then this starts to become pretty crowded if everything sits just over here under the tests folder. Okay, so now that we have this, let's go ahead and create the actual test project. So for that, let's use the .NET CLI. So over here, let's go to our tests project, specifically into the unit test, and let's create here a new XUnit test project. Okay, so the name of the project is simply the name of the project that we're testing with the unit tests suffix. Okay, so I went ahead and created a test project per project other than the contracts project. So the contract project is simply a class library that contains the definition of our API, and it doesn't need unit tests, at least as it stands today. The next thing we want to do is we want to go to the solution file and update it to reference all the new projects. So what I'm going to do for that is I'm simply going to delete the SLN file, create a new one. So let's say .NET new SLN, and we're going to simply add all the projects that exist now because we also changed the structure of the files. So the previous reference to the projects as it was before isn't valid anymore. So .NET SLN add, and we want to add a reference to all the CS projects that exist recursively. So running this will create the solution file as we want. The next thing we're going to do is we're going to look at the command handler that we're going to write the test for. Now, the emphasis of this video is not the actual test that we're going to write, but it's all the infrastructure around it, building a small framework that's specific for your application when you're building tests. So I want you, even though we're looking at the code that we're using in this video, I do want you to imagine the code that you're working on in your code base and think how you can apply some of the principles to create structure in your test project. So we're going to write the test for the menu command handler. So this one over here. And what we have is a simple command handler that all we're doing as part of the logic of this method is we're creating a menu aggregate based on the create menu command. We're adding this menu to the menu repository and we're returning the menu over here. So it's very straightforward. There isn't a lot of logic over here. Again, we're going to write the code for this, but I want you to notice the structure and the framework that we're building as we're going along. The first thing we want to do is we want each one of our tests to sit in the corresponding folder path of the original source code. So we can see over here the folder structure leading to our handler because the namespace corresponds to the folder structure. So we can see we have the menus folder, then the commands folder, then the create menu folder. So let's go ahead and recreate the same hierarchy in the test project. So over here, we can go ahead and say menus, commands, create menu. This will create the 3 folders. And the name of the class we want over here is the name of the source file with the tests suffix. So let's say create menu, command handler, tests. Okay, so we have our test class. The next thing I want you to notice is the following. So we have a single test file corresponding to the source code file. Sometimes the source file, just for legacy reasons, may be really big. This means that if the source code is very long, then the test file will be much, much longer. And of course, that isn't scalable, maintainable, or fun to work with. If you have many sub-scenarios inside the same source code file, then you may want to do something like the following and simply create multiple files per sub-scenario. So let's say you have a sub-scenario of creating a menu inside this. So you would say create menu tests, right? Something like the following. And you would have a file that would contain the logical subgroup of tests for that scenario. So if you're writing the first test for this God file, you want to think about what will happen in the next 10 pull requests when all the following tests will be added, and what will happen to the file. Will it become a God file? And should you already put the initial infrastructure of creating files specifically for a smaller scope? Okay, the next thing I want to do is talk about the test naming. So for us to be able to see something, I closed the folder view, I'll split the screen, and on the right-hand side, I'll put the source code that we're testing. For the test name, I go with the following structure. So let's say public void, and it's going to be divided into 3 parts. So T1, T2, and T3, where T1 is what we're testing, so the system under test. T2 is the specific scenario that we're testing, so scenario. And T3 is the expected outcome, right? What we expect to happen in this scenario. So expected outcome. For the system under test, the reason why I think this is important is we want from the test name to know what part of the code we're talking about. So when I see this failing in my CI/CD, I see, okay, what's failing is, for in our case, handling the create menu command. So I already know to associate it with the corresponding part in our application that is failing. So this is basically what we're testing, and it doesn't have to be the exact name of the method or the class that we're testing. So in our case, it doesn't need to be create menu command handler, but it needs to be the logical association to the piece of code that we want to test. Okay, so this is what we're testing. The next one is the scenario. So each one of our tests is testing a specific scenario. So perhaps let's say here, this is what we're testing. This is the logical component that we're testing and the expected outcome like it sounds. So what we expect the logical component to do. Like I said, unit testing is highly opinionated, and specifically test names is highly opinionated. So this is specifically what I think is the best approach after seeing many projects using various strategies. The reason why I like this approach, even though we're putting over here perhaps details of the name of the class, so we might, when changing the name of the class or refactoring, we might need to change the name of T1 in 30 tests. So yes, that's true. But the reason I like that, again, is when I see a test failing, So as the application grows, we have thousands of tests. A random test somewhere in the code base breaks. I know how to do the logical association with the specific code that failed. And for T2 and T3, what I like about this is that it tells you what the test is going to do, what you're expecting to have in the outcome. And once you have this structure for all the tests in your code base, so it's very easy to open a random test and understand what it does without having to read through the implementation of the method. So in our case, let's say handle create menu command, and the scenario that we want to test in our case is, for example, when menu is valid, then what we want to happen is that it should be added and returned. So let's say should create and return menu. Okay, so I want to contrast what we're doing with some other very common approaches. So this is something that I've seen in way too many code bases where the main flow, the flow that the unit that we're talking about was created for, will be called test underscore happy flow. What does happy flow even mean? Should we be sending a metric when we're creating a new menu? Should we be logging the information? Should we be raising an event? Should we be adding it to the database? Should we not be returning the menu? This doesn't have any details about what's actually supposed to happen. And it would require me as someone joining the code base to go through the test method and understand what the happy flow is. And when this test doesn't only contain one specific scenario, many times this test becomes a big test that tests multiple scenarios in the same method. It becomes a mess, not only to understand, but also to refactor. And every time you add something, you got to think, is this part of the happy flow? If yes, I need to go to that method, update it, and so on. So I highly dislike this approach. This is probably the worst approach, in my opinion, when it comes to naming the tests. The next one is something like the following. This is very common and it's suggested by many of the pros. The reason I dislike this is because it's lacking the structure needed in a team environment to create tests that look in a uniform way. What I mean by that is that this is a great name that perhaps we thought of, but someone else may call it something like the following. Each one of these two names is a valid name for the test that we want to write, but because it lacks structure, it requires more cognitive load to understand what we're testing, what the system under test is, and what the expected behavior is. In my opinion, when you have something like this, then even if team members slowly create their own style of naming that is a bit different, it still stays more or less under the same umbrella of test naming. And approach number 3, which is also pretty common, is something like this, but very fluid rules. So if you need to add another underscore somewhere in the middle, then go ahead and do that. And very quickly, you'll have tests that are written something like this. Specifically within Microsoft, something like the following is super common. So you'll have test underscore, and then, for example, the system under test, and something else, maybe some other sub-scenarios that we're testing. This not only becomes long, but requires also the cognitive load of understanding what this method is testing. And also, when you're writing a test in this code base, then it requires more time to think what the name should be to align with the other tests in this class. So this is what I'm suggesting. You can do, of course, whatever you want, but in my opinion, this is the best approach. Okay, now you may be asking yourself, why are we talking so much about the name of the test? If we're only writing code that tests other code, then why do we even care what the name of the method that isn't even going to run as part of production code? Who even cares what the name is? In my opinion, having a strong convention for the name of the test is actually very important. The reason for that is as the application grows, we have hundreds of tests, thousands of tests, and if each one of the tests is written in a different way, it becomes much harder to write the tests trying to align with the code around you. Also, if some random test is failing and you want to understand why it's failing, it will save you a lot of time in trying to understand what happened. Bigger projects with more team members usually means that there's going to be less focus on the test files during code review. This means that the threshold for writing bad code for tests is much lower than the actual production code. If there aren't good conventions out of the box as the project is set up, then people will copy paste bad code and it will require much more development time as time goes on because it's not well structured. Even if this conversation seems a bit ridiculous to you, I do want you to remember that some projects can really benefit from having this type of convention. So with that out of the way, that's the name of the test that we're going with. The next thing we want to do is we want to write the actual code. So I'm a big proponent of arrange act assert. So let's say over here, arrange act assert, and I'm not going to go into detail because I'm assuming you know the theory of unit tests. So in the arrange, what we want to do is we want to somehow get hold of a valid menu. In the act, we want to invoke the handler, and in the assert, we want to check two things. The first one is that the correct menu was created based on the command that we gave, and the second one is that it was actually added to the underlying repository. So let's say validate correct menu created based on command, and number two, menu added to repository. So the first thing we want to do is we want to get hold of a valid create menu command. And for that, we're going to start creating some mini framework for our specific project. So let's open the folder structure and look where we are. Okay, so again, we're over here. We have the menus folder, inside that the commands in the create menu, and over here is our test class. Now we want to create a utility specifically for creating the create menu command object. Now the question is, where do you think we should place this utility? What most projects do is the following. So they would have over here in the top folder of the project, they would have something like test utils, and the various logic will sit under here. The reason why we want to avoid this is because as the application grows, this becomes a God folder for all the various utilities, even without talking about how it's structured deeper inside. What I like doing is putting the utility class as close to the components that are using it as possible. That means it'll sit nested inside the folders as deep as possible that still allows the various components that are using it to use it. Because in our case, we're talking about a utility for creating the create menu command object. This probably won't be needed outside of this commands folder. So for that reason, we're going to create over here the test utils class, and the utilities that are needed for this subcomponent and inside recursively will sit over here. Now, of course, as the application grows, things change. So you can take the utility that's sitting in a nested folder and put it outside. So in our case, this is what we want. So let's go ahead and create the create menu command utils file. Okay, so it's tomorrow because I'm a parent and I had to stop filming yesterday. Continuing where we left off. So like we said, we want to create the create menu command, and each one of the commands looks as following. What I'll do is I'll split the screen, and on the right, I'll put the command that we're trying to create. So like we said, each one of the create menu commands has a name and a description and the host ID, which is the ID of the host that's trying to create the menu. Then we have a list of sections, and each one of the sections has a name and a description, and also a list of items where each one of the items also has a name and a description. Now, if you're imagining a menu in a restaurant, then as you know, each menu has a lot of sections and each section has a lot of items. I'll put the JSON representation of the menu on the screen so you can pause the video, and once you have that imagined, then we can continue. So now the question is, how do we create one of these command objects in a way that's also small building blocks where many unit tests can use it, and also it's not too generic, requiring each one of the tests using this utils class to write a lot of duplicate code. But before we do that, we need to add a reference from the test project to the source code project. So for that, let's say .NET add, and we want to add a reference from the unit tests project to the original source code that's sitting behind it. Then we can say the following. So public static, what we want to create is one of these guys over here. So that's what we want to create. Let's call it create command. So let's say over here, this returns a new create menu command, and let's populate it with some values. Now, because we want to have various test constants that we're going to use for the various objects. So for example, the menu name, instead of rewriting it in hard-coded strings across our test project, we want to have it defined in one place. Because these are utilities that are across our test project, then we don't want it inside the test utils over here, right? So again, I'm reminding you that we created the test utils inside the commands folder, but we'll want that inside the test utils of the entire test project. Over here, let's create a folder called constants, and this will contain all the constants for our test project. Now, instead of creating a single test constants file, which will become a God file as time goes on, instead what we're going to do is we're going to take the following approach. We're going to say constants.menu.cs, and this will contain all the constants specifically for the menu feature. Okay, so public static partial class constants, and what this will contain is another static class called menu, and over here we're going to have public const string name. This will be the name of the menu that we'll use across our test project, and let's call this menu name. And for the description, so let's do the same thing. Let's simply replace where it says name with description, and now we have the menu description. Okay, so I did the same thing for the section and the item. So we have menu section name, menu section description, and same thing for the item, but with item. Now that we have this out of the way, the last thing that we're missing is the host ID over here. Now, because the host ID belongs to the host, then similar to what we have over here, let's create another file and let's call it constants.host.cs. And this is going to be similar to what we have over here. So let's simply copy, paste what we have, change this from menu to host. Let's replace everything we have over here and let's add the host ID. So let's say public static read-only host ID. This is coming from the domain project. So you'll have to add, I did this off camera, you'll have to add the reference from the application unit tests to the domain project, similar to what we did before. So let's say host ID, let's add the reference and let's call it ID. And I'm reminding you that the host ID looks as follows. So we have over here the create method that receives a string and returns a new host ID object. So what we're going to do is we're going to say host ID equals host ID dot create, and over here we'll give it something, let's say host ID. The reason why I like this approach is because now each one of our features or resources has its own smaller scope where it contains only the constants for that specific type. Then as application grows, you add more files, each one with its specific scope, and it doesn't become a God file. Now, if you're looking at the menu, then over here we have also the relevant resources for the menu, but we also have here things for the sections and the items. If this starts growing and becomes a God file, then of course you can split this up further and create a menu sections or menu items and so on. So now that we have this, we can go back to the utilities class. Over here, we can now say constants.host.id.toString. This will give us the host ID. Next, we can do the same thing, but over here, say menu and choose the name, and same thing for the description. The last thing we need to specify over here is the list of sections, okay? Now, this is where it usually goes wrong in most applications that I encounter, and I want to propose something else, and I hope that you'll apply this in your projects as well. So over here, we need to create a list of menu sections. For that, let's create a new method that knows how to generate a list of menu sections based on the number of menu sections that we want. Let's actually copy this entire method, paste it over here, and let's remove this. And what this receives is also the number of sections that we want to create. So let's say section count, and it will create the number of sections based on this count. So for that, we can do the following trick. We can say enumerable.range. We can give it the range from 0 until the section count. And over here, we can select, and based on the index that we have, create a new menu section. So we can say over here, new menu section command, and finally to list this entire thing and return it. Now to create a new menu section command, we want each one of the sections to be unique, meaning we don't want all of them to have the exact same name and description because that can cause bugs that we're not aware of because we're comparing two different items, but they have the same name and description. So we think they're the same, even though they are not. So what we can do in this case is a very neat trick. Let's do the following. Let's go to the menu constants. And over here, let's create a new method that will know how to generate a new menu section name based on a given index, okay? Because it's very common when we have a list of menu sections that we'll want, based on the index inside the list, to have a unique name and description. So let's say over here, public static, and then we want to create a section name from a given index. So that's a section name from index. Let's give it over here the index that we're creating the section name for. And what this will return is simply the section name that we have above and the index. And now we have something that's specific for this index. Okay, let's just specify the return type, and maybe let's put this on a new line so it's visible. Okay, now that we have this, then we can do the same thing for the section description and for the items. So I'll write it out and then we'll go over it. Okay, so here we have it. We can create section name and description and item name and description based on a given index having something unique. Then what we can do is we can go back to the test utils over here, and we can say the following. Each one of the sections, again, has a name and a description. So for that, we can say the following. Let's say constants.menu. And then we want to get the section name from index, and the index that we want to give it is the current index. And we want to do the same thing for the description. So let's say over here, description, and this will give us what we want. Okay, now let's do the same thing for the menu items. Okay, so I wrote it out, same thing like we have over here, but I replaced where it says section with item. Now, one thing that I did notice is that this should be plural because we're creating multiple items, and also the return type needs to be a list because, again, we're returning a list of items. So let's do the same thing over here. Let's change the sections to sections. I changed this to be a list of menu section commands. And then over here, we can call the create items command, and we need to specify here a section count. Let's say by default, when you don't specify a count, then the default is 1. Let's do the same also over here. Great, so we have that. Let's align the parentheses. Let's to list this. And now that we have two of these out of the way, we can get rid of this, and finally over here, we can call the create sections command, which will create the list of sections. Okay, now because this can return null theoretically, so let's silence the compiler telling it, don't worry, this can't be null. Now that we have all this written out, there are still some things that we're going to change here in a minute, but now we have 3 components. One of them knows how to create the command, one of them knows how to create a list of sections, and one of them knows how to create a list of items. Now let's go back over here, and we can create a valid menu by saying over here that we have the create menu command equals the create menu command utils, and we want to simply call create command. Okay, so we want this type of abstraction where we simply call create command, and behind the scenes it creates the corresponding command in a valid way without us having to do it manually inside our test, reducing the cognitive load of anyone looking at the test, simply saying this, okay, great, this creates the command, what happens next? Okay, so now that we have this out of the way, the next thing that we want to do is we want to invoke the handler. All I did was create a new instance of the command handler. So if we're looking over here, then we're simply calling the constructor over here, and we still need to specify the menu repository. For that, I'm going to use mock, the library for mocking objects. I'm assuming you all know already the theory behind it, so I'll write it out and then we'll cover it briefly. So we're going to add the package mock. This will add the library that we need, and then we can go ahead and create here the repository. Okay, now I do want to say that I like the prefix of mock for mock objects because, again, it reduces the cognitive load of looking at each one of the objects and trying to understand if it's the actual concrete object or if it's a mock of that object. Okay, so now that we have this, let's go ahead and invoke it below in the test. So let's say over here that the result equals, and over here we want to await calling the command handler because it's asynchronous. So let's say over here async task, and over here let's say that we want to call the handle method. And over here, we want to pass it the create menu command. And for the cancellation token, let's simply pass default. Now that we have the result from the method, what we want to make sure is that the correct menu aggregate was created based on the create menu command, and also that the menu was indeed added to the repository. Now, because what this returns is an error or the menu aggregate, so the first thing we want to do is we want to make sure that it is not an error. So for this, we're going to use fluent assertions. So for this, let's simply add fluent assertions, and now we can simply say should be false. The next thing we want to do is we want to validate the values in the menu, that they were constructed according to the values that we specified in the command. Now, to do this, again, we want to build it in a way that as the application grows, more validation methods like what we're going to right now are going to sit in a single place, so it's easy to refactor or change as the application grows. So for that, what I really like doing is creating extension methods, because again, it reduces the cognitive load when I simply want to make sure that the menu was created from the command. Then all I can write is the following. I can say result.value, which is the underlying menu, and I can say validate created from and pass it over here the command as so. So let's write this extension method, which will have inside all the logic that has to do with validating the value. So for that, let's create here a new folder and let's call it menus. And over here, we'll create another folder. Let's call it extensions. And what we'll have over here is, again, multiple files with extensions on the menu aggregate, so that we don't have an extensions God file that contains all the various extensions that we might have. So let's say menu extensions.validations.cs. Okay, so I wrote out the validation logic, and what we have here is the following. So we have a method that receives both the menu and the command, and it goes through all the various properties and validates that the correct value from the command was assigned to the correct value in the menu. Okay, now a small trick that you can do, if you're not aware of it, is that if you have two lists and you want to take the pairs of them by index and make sure that they have the same values, then instead of doing a for loop where you're creating an index and then you read from the list in that specific index in both of the lists, then you can simply zip them together. So in our case, we're zipping the menu sections and the command sections, and over here we have a pair where we have them, the corresponding pairs within the two lists, and then we can compare them. So that's just a nice trick that if you're not using and you like it, then you can consider using. Okay, so now that we have this, let's go back to our test method. This validate created from method now exists. What I like about this approach is that we have the good type of abstraction where I don't care about how this thing is constructed, but I know I have over here a valid create menu command, and over here, I'm validating that it was constructed correctly. The last thing that we're missing is making sure that the menu repository was called with the exact same menu. So for that, all we need to do is we can say mock menu repository, and we want to verify that the add async method was called specifically with the menu that was returned from the method, and we want to make sure that it was called exactly once. Okay, so we have that. It's starting to look good, but what if this specific create menu command is valid and it runs through the test successfully, but other variations that are also valid of the command don't run successfully, right? So we're not covering those cases. So what I'm gonna do is extract this and put different variations of valid menus, and then we have this single test that's testing all the various valid menu commands. So what we're going to do for that is we're going to do the following. So let's say over here, theory, and over here, we're going to create a member data, where over here, we're going to have a method that will create multiple valid menus. So let's say over here, valid create menu commands, and let's generate this method. And what this is going to return is, as you probably already know, this needs to return an IEnumerable of type list of objects. And to get rid of this squiggly line, let's say over here that here we have the create menu command, right? So let's take this thing and paste it over here. And now we can remove this entire thing. We still have a squiggly line, and that's because this should be public and static, So now that we have that, great. Now what we want to do over here is return multiple valid menus. So what I removed from over here, let's paste it back inside this method. So let's say over here, yield, return, and over here we want to create a new list of objects where what we're doing is calling the create menu command util and create command, this thing. And this will be similar to what we wrote before. So we have this, but we also would like different cases where, let's say over here, we have 3 sections and another one where we have 3 sections and each one of the sections has also 3 items. Now to test that case, what we want to do is update these methods to be a bit more flexible, where we can update the way the command is constructed. I want to encourage you to pause the video, look at the utils class that we have over here, and think how you would update the methods over here to support creating a create menu command where we have a custom number of sections and a custom number of items when creating the create command method over here. So the wrong answer, in my opinion, is saying over here, let's pass the section count and the item count, and then we need to pass over here the 2 counts down and then pass the item count down to here. Instead, what I like doing, and I think is more scalable, again, we want small building blocks that as application grows and we have more and more variations of this create command, the parameters over here doesn't become a list of 100 parameters where then you have edge cases where you say, oh, maybe I'll just pass here a boolean, and then if it's true, then I'll do this, and if it's false, then I'll create the object in a different way, because then this becomes a god method of creating the command. Instead, what I suggest is the following. So over here, we'll call the create sections command only if the user didn't specify a list of sections. So let's say list of create menu section command, and this is going to be optional, and we're going to say sections. And if we didn't specify sections, then we'll create the basic sections as we had before. So this still works like it worked before. What's nice about this is that now we can do the following. Let's call the create command, but now we can specify the sections over here. So we can say this thing sections command and specify here that the section count is 3. Like we said before, let's just add a trailing comma over here, and that's it. Okay. Now the same thing for the items. So let's say we want to create another one over here where this time we have a custom list of items. So going through the exact same logic, let's say over here that other than the section count, it can also receive an optional list of items. So let's simply copy this thing over here, paste it down here where it says section. Let's replace it with item. Let's say items, and let's say that if we didn't specify items, then it's going to call the create menu command. Okay, so again, when constructing complex objects, then we define optional parameters with the inner objects, and then if they're not specified, then we create some default, otherwise we use them. This is true for the inner objects as well. So for the section, then also over here, we receive the optional list of items, and if it wasn't specified, then we create it over here. Okay, so now that we have this, then we can go ahead and say that the section count is 3, but the items isn't the default, but we want to create our custom item. So let's say over here, create items command, and let's specify the item count. Sorry, we called it section count. Let's change this to be item count. So let's pass it the item count, which is 3. Like we said, we're building a small testing framework for our specific domain or application. And now what we have is we still have the create command, which is generic, and everything else stays generic as well. So now when we want to test creating an invalid menu, then all we need to do is follow the same logic for the name and the description. And then, for example, if we want to create an invalid menu where the name is invalid, then all we need to do is define the name as a parameter as well. Then if the name was specified, then we use that. Otherwise, we fall back to the default and we follow the same logic, building small building blocks throughout our unit test project. Now I'm saying unit test project, but of course, many of this can apply to any other test project that you're created. I want you to take the idea of breaking down whatever code in the unit test project that you're writing, breaking it down into smaller components. So as the application grows, it grows horizontally. So we're adding more files with specific logic instead of growing vertically where you have a single file that more and more methods are added. The reason why I like this approach is because now when we need to do the same thing for the create dinner command, then whoever's going to implement that will take a look at this and will probably copy paste this code, change where it says menu to dinner, and put the same logic over there, maintaining the same code structure in the future tests or test utilities that will be written. So we have our single test method. Maybe let's remove all these redundant comments. Let's put a breakpoint over here, and actually also in the command handler. Let's put a breakpoint over here. Okay, so we hit the breakpoint, and first of all, let's make sure that this create menu command was constructed like we expect. So looking at the name, the description, and the host ID, it looks yes as we defined. And looking at the sections, so we have one section, and this one section that we have has the section name and description with the index appended to the end. And when it comes to the items, then we have the exact same thing with 0 appended to the end. Great, so this looks as we expect. Let's continue, and we hit the breakpoint inside the command handler. Let's step over this, and we created the menu aggregate based on the values that we specified. So we can see over here that indeed we have the correct values that correspond to the command that we passed. We're calling the add async, and because this is a mocked object and we didn't define a behavior, then nothing happens over there other than registering the call was made. So we're returning the menu. Over here we have the is error. The is error is indeed false. In the value we have, like we said, the menu aggregate. If we step into this, then we run through the various validations to make sure that all the various values were assigned correctly. And finally, we want to make sure that the add async was called with the exact value that we specified and that it was called only once. So continuing, and when we run through this again, then now we should have the create menu command, and this time it has 3 sections, but 1 item per section. And this is indeed what we have, and we want to make sure that the name really is unique based on the index of the section. Okay, so let's click continue. I think you got the idea. Let's run until the end. Okay, so the tests passed successfully. So overall, what we have is the following. We have the tests file that sits in the same hierarchy based on the source code that it's testing. Then we have a test utils that sits as close to the code that uses it as possible. So if this now is used by other components that are outside of the commands folder, then we'll take it up to the next folder in the hierarchy. Then we have the general test utils that are used across the entire test project. And inside here, we're trying to break it up into smaller components so that each one of the files doesn't become a God file. Lastly, we have creating complex objects where we pass the inner objects or properties as parameters instead of passing the logic that we want for the inner object construction as part of the parameters of this method. So we don't want any logic that has to do with sections passed as a argument to the create command method. Okay, so I hope that makes sense. You learned something new and that you already see places in your application where you can apply it. If you disagree with anything that I wrote, then of course don't do it in your application. This is definitely up for preference, but do let me know in the comments what you like to do and if you like doing it otherwise, because I think it will start some very interesting conversations between different projects that have different patterns. So I'm curious to hear what you think. Let me know in the comments. And if you enjoyed it, don't forget to hit the like button, smash the subscribe button, and I'll see you in the next one.